This instructional video is designed to demonstrate the basics of using the common logarithm, base 10, in doing some standard mathematical manipulations. And so we have three key features that you have to understand, and then one demonstration of how this all works together. So the first is the definition of a logarithm. It defines a relationship between two numbers. So if we take the logarithm of number x that has value y, what this means is that the number x is equal to 10 raised to the y power. The natural logarithm uses the base e, which is an irrational number, and it retains the same thing, except here you'll have ln of x equals y, means that x equals e to the y. We'll find out in other demonstrations why we use base 10 and why it works so well for us. The multiplication rule. So let's suppose you have two numbers, a and b, and you're multiplying them together. The value of the logarithm of this product can be found as a sum. So the first half of the sum, we'll use green for a, is the log of a, and we'll use blue for b, log of b. So for multiplication, the logarithm creates a sum. The next thing we'll do is we'll take some number a and we'll raise that to some power n. So if we want to take the logarithm of a raised to the n, then the rule for handling the exponent requires that we do a multiplication. In this case, we will multiply by the exponent, and the number that we're going to take the logarithm of is just a. So with these two rules, we can do an example that involves division. So suppose we have two numbers, a and b, and we're going to divide them. For that, I'll again use blue for a, green for a, and blue for b. So if we're going to take the log of this, we have to recognize a couple of things. The main one being that this is a times 1 over b, but the quantity 1 over b is itself equal to b raised to the negative 1 power. And so we now have that this is equal to a times b to the negative 1. So if we want to take the logarithm on both sides, and I'll use black for that, that's going to be equal to the log of a product where one of the items in the product has an exponent on it. So what this means then is that we're going to have log of a plus the log of b raised to the negative 1 power. And because we have this negative 1, we expect this to be negative 1 times the log of b. And so what we'll find then, getting rid of all of the coloring, is the following for division: that the log of a divided by b is going to be equal to the log of a minus the log of b. And while this may look like a brand new rule, it's actually just an extended application of the rules for multiplication and exponentiation. In another video, you'll see us using the definition of logarithm to show how it's possible to estimate values of logarithms without the use of advanced scientific calculators.